Alright, so welcome to the Squid part of this tutorial. So this is one I'm actually super excited about. So here we have the squid creature, and let's play through this. You can see it's a little bit slow. Well, it's actually still quite fast, but I mean for the amount of stuff that's going on, it's quite fast. But so a lot of stuff happening here. So we have this squid. We have these eyes sort of randomly moving about. We have these tentacles that are moving. There's velocity being generated for the motion blur. So if I go to the wireframe, you see the top thing is actually quite detailed. And the whole thing is completely procedural. So if I go in here, let's make this thing a little bit bigger. So I could go into the eyes, for example, and I could say I want less eyes. So now it only has a couple of eyes. There's so I didn't make upper level control for this thing, but you could definitely do that if you wanted to. So there's controls for like the bending, like the top part. So you can see this the bending. There's just gotta see a little bit where I'm doing all the things. So there's the controls for the shape of the thing. So we could make it look really weird. You could have an alien look like this. Well, a squid look like this. You could make it like this, and then you could do something like that. You can have all of the control you want. So the whole thing is like super procedural. Just has a lot of super cool stuff going on. So I have control over like where the eyes are scattered. You see, there are a lot of techniques that we also used in the seaweed. That's why we did the seaweed before. So yeah, you can see now they're not scattered at the bottom. So let's undo a couple of steps. So, and all of this is sort of built up into sort of different steps. So we have the head here. We have the eyes going on over here. We have sort of this, which I don't know what they are, but I thought it looked cool. We have the tentacles themselves, which are moving like that. Of course, we have control over how much they move and how fast they move. We have these little like sort of knobs. I'm not sure what they call it, but we have these knobs happening. And when you move, like merge everything together, you get the squid. And you see there's a whole bunch of nodes here that we haven't used before. So we're going to learn a whole bunch of new stuff. And I know this looks intimidating, but we will start building this thing from scratch. Final node tree from the tutorial might look a little bit different because it's a lot of stuff. And when you're working, you're generally just putting stuff down and trying stuff out. But we will go through this thing, make our little squid, and by the end of it, you will have learned a lot. So super excited for that. So let's dive in. All right, so let's just hide this one. Let's create an empty geometry node. I guess call it Squid tutorial. Let's dive in. And I am going to keep the other squid as a reference for myself because it's a lot of stuff going on. So I kind of want to sort of have it as a reference for myself so I don't randomly put down stuff in the wrong order. So just keep that in mind. So I'm just going to go over the stuff that's happening and then build it on top, build it on here, and then go through why we did certain stuff. Right, so if I go on here to the right, you see we start off with a simple line. So let's do that. Let's create a line. You can see the line is just, it has a certain length. So and here I see I made it 0.7. So let's make it 0.7. And it had a certain point count, but that doesn't really matter that much because we are resampling it, just like we did with the seaweed. So if we put it down, you can see we get some more points. Let's make it 0.3. So if I go in here, you can see we get some more points. So as you remember from the seaweed, why do we do that? Well, if we go in here, you see we're binding the curve U, we're ramping it, then we're multiplying it, and we're binding it to p-scale. So you can go ahead and grab, if you want, that from your seaweed tutorial thing, or we can build it again ourselves, maybe just to show. So what we do is we just bind curve U, then we ramp curve U, then we put down a multiply. And again, this needs to be a spline ramp because it needs to be a because we want, like if I make a color ramp, it will be colors over here. So we want a spline control like that, right? We put that in there. And we want to export is p-scale, because p-scale is what we're going to use on a lot of places, because p-scale is being recognized by a lot of stuff in Houdini. So bind export. And again, remember the resample, it needs to have curve U turn on, so like that. And remember that will put down an attribute here. And what we could alternatively do, if you like, for example, to wrangle more, let's show how this is done in a wrangle. Right, so let's make an attribute wrangle. Let's put it in here. So if we look what's going on here, we have a ramp, and the ramp has curve U plugged in. So let's make a holding variable called p-scale, and we're gonna say that the p-scale should be channel ramp. So ch ramp will create a ramp, call it, I guess, p-scale ramp. So this is our name as a string. And then what will we plug into it? We will plug in curve U, right? If we press the button, then we don't get anything. So why don't we get anything? That's weird. Okay, now we did. Oh yeah, sorry, I had the space in between, which obviously doesn't work because the channel name needs to have no thing. Well, anyway, so now we get this ramp. So right now it is not writing out anything. So if I go in here, you can see it's not writing out any p-scale. What we want is a multiplier for our p-scale. So if we type p-scale like this, and then type times equals, and then type channel f, so channel float, and then call it multiplier maybe, like that. And then if we press the button, then we get a multiplier. And then let's say that f at p-scale. So if we type f at, we're going to create a float attribute with an at and then a name, you create an attribute. So attribute kind of makes sense, right? So f at means float at p-scale, and then we're going to tell that p-scale attribute should be equal to the p-scale attribute we set here. So float p-scale, so this will create a float called p-scale, which will be the ramp, which will ramp the curve U. Then we tell the p-scale to be multiplied by something, and then we write it out. So let's have a look in our spreadsheet. And then you can see we basically did the same thing. So I don't think we created a multiplier here yet, so let's promote this. So same thing. So use whichever you want. I just wanted to show also how that works in a wrangle, so you can slowly get the grips on how it sort of works as a wrangle. So I'm going to do that more often with some of the nodes, just to show how you can how to read VOPs and then sort of convert it into VEX. So because for some people, just VEX makes more sense than VOPs, I've noticed. So And for most people, more creative, like mostly creative people find VOPs easier to understand, and most like people with coding background find Vex easier to understand. I was more in the VOPs crew when I started out. I was doing everything in VOPs, and then I slowly moved more into Vex, and now I mix and match whatever I'm doing. I always do noises in VOPs, but so anyway, let's move along. So just so you know that you can use both. Right. So then what we're doing is we're copy 2 points. We can plug something into there. Let's make not a line, a circle. You can see I make a circle here. It's a polygon circle. So this will have multiple types. So if it's a polygon, it will be like this. By default, it's a primitive, which is more like so it only counts as one point. It's more like a perfect circle, but it doesn't have any polygons, which you can edit. So let's make it a polygon. And it has a ton of divisions. So it gets like nice and round. And let's make it on the Z-X plane. So it's flat down like that. And then we can plug it into our copy 2 points. And we don't want to pack it because we need the geometry. And then we can say a shape. So if I go look at pin it to the second one. So you can see I'm creating sort of this type of shape, which I'm doing inside the thing. So if I go into my sort of curve, let's try to sort of recreate that look. And again, you can select points and then right click set interpolation to Bezier. If I now go back to my initial thing, you can see it's sort of similar. So the P scale is what the thing is doing, it's copying a circle to every one of these points. And the size will depend on the P scale of that point. So if I make a visualizer for my P scale, we can see the P scale. So it's the same as here in the geometry spreadsheet. You can see the P scale for every attribute. And the thicker, like the higher the P scale is, the bigger the copy will be. So just to sort of reiterate what we've been doing so far, so it sort of makes sense. All right, so we had a bend after this, but before we do the bend, because let's first do this thing afterwards, skin. So what will skin do? Well, skin will basically take our primitive, so we have here, and it will build a mesh from it. So now you can see we don't have the stuff on the inside anymore. It just has the stuff inside there. So again, if we look in here and disable the bend, you can see we get that. So maybe we want to have this thing be a little bit bigger on top. Now we create this sort of nice shape. Right. So now let's say we want to sort of be able to bend this this thing a little bit. So let's make a bend. Let's put a bend in there. So the bend will. So this is a new bend in Houdini 18. There was it's better than the original one. But it's still sort of similar. So you can say set capture region, and we'll sort of automatically set a region. We need to give it a direction. So it needs to capture it in the up direction. And that thing doesn't understand. And we need to say a capture length. So kind of needs to be the height of this thing. So what we can either do is so there's multiple ways to do this. So we can either say that we want to sort of manually set it. So like it needs to be somewhat this high, which is one way to do it. Another way to do it would be to copy the length of this line and then just paste relative reference. So now you can see that no matter how long the line, like if I make the line bigger, the bend will just follow. Let's undo that. Another way to do this, so there's 1001 ways to do anything in Houdini. So remember when we did the centroid expression? Well, there's another expression called bbox. And bbox will check for the bounding box of an object. So if I type bbox, and again, this is in the PDF that's downloadable on my website. And what do we want to check the bounding box from? We want to check for the copy to points. And we want to check the t, the y, and then the max. So the maximum size of the y position. So it's going to check the bounding box. So that's the box around here. And it's going to check this thing and then the maximum size. And this will also evaluate to the maximum size. So if I increase the line, this will work. So again, there's 1001 ways to do this. I'm just showing all these different ways so you can sort of get a grip with all these different tools and expressions. And everybody has their own way of working. And now if I just skin this, you can see we get sort of a skin thing. Right, so now we're going to do something that I actually didn't do in my original thing. Is first we need to reverse this. So we get like our stuff nicely pointing outward. But we have these gaps. And I do want to keep the gap on the bottom, because if we look at our original thing, it's like open, and I liked how it's open. You could also have it closed. But I want to keep it open. I kind of like the way that also the light was sort of bouncing through it that way. So what we kind of need to do is we want to fill this. So let's convert. We need to convert it first, because the skin is not making proper polygons, I think. I'm not sure what it's actually creating, but in order we need to put convert, so it will get proper polygons. And now we can type polyfill. Right. So what polyfill will do is fill gaps. So if you can see, if I have to convert, it's open. And if I do polyfill, you can see now it's closed. So if I look, you can see it will create quads. I actually don't want it in this case. So let's put it to single polygon instead. So now we don't get quads. You might think, oh, angles, oh, heresy. Well, the reason why we're doing this is because we want to blast away the bottom primitive. So how will we do this? So this one is primitive 1200. So you could say, okay, we need to blast away primitive 1200. But let's say if we change the division size here, so now it's 2350. So the top one will be wait 1 second. Why is it not? All right, let me go to. So the top one will. Oh, it's not in this case. It's also just a because they get added. They get the new primitive numbers. But we can say that we want the bottom one to be 0. So how will we do that? Well, there's a sub called sort. If we type sort, this will sort points or primitives or whatever. So you can see by highlighting this, I see all my primitive numbers, which you would now sort of wrap around. You can see 1, 2, 3, 4, 5, 6, 7, blah, 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 and they just keep going up. What I can say is that there's point sort, there's primitive sort. Let's put the primitive sort to the Y position. So it's the upwards position. Let's put it to Y. Now you can see it's still going 1, 2, 3, 4, whatever, but the zeroed primitive will be the one on the bottom. If I were to reverse this, it will be the one on the top. So now, no matter what I do, like if I change this, it will always be the zeroed one. So now we can confidently blast away the zeroed primitive. Goodbye. Right, so now we're sort of left with the same thing. So that was something I hadn't done in the original thing, but it's really better to sort of do it this way. And we have full control over our shape and everything. But now just the top one will be closed and the bottom one will not be. So just a quick little thing. Right, so what I actually had in my original thing is an auto UV to create UVs, but I actually didn't end up using UVs for rendering. What I ended up using was triplanar mapping. So if you don't know what triplanar mapping is, So if you don't know what UVs are in general and you're like completely new to 3D, so let me show you the thing auto UV created. And accidentally created. Press the button. So UVs will be a 2D unwrap of your 3D geometry. So something like this. So think of origami. So this will allow you to sort of map textures on an object. I didn't end up doing that because I was using triplanar. So triplanar will just at render time project like UVs from 3 planes on your geometry, so you don't need UVs. But in order to make the tutorial a little bit more complete, I am going to show you how to just quickly unwrap this thing, even though we don't really need UVs for the final thing. Because by default, Houdini doesn't have UV. So if you press Shift 5 in the viewport, you go to UV view. So with Shift 1, 2, 3, 4, you can go to different views like that. So let's say we want to unwrap this thing. So there's a thing called UV flatten. So if you in the viewport type space and then type UV flatten, it will tell you what to do. Easy enough, right? We just follow instructions. So select the polygons to flatten, select all the polygons, press enter. Okay, let's do that. Select seam edges. So probably we want the back edges. So let's select some edges and select the top edges as well. Boom. All right, and press enter. All right. So now if we press shift space, we get this UV layout, but it's like not fitted properly. So if you type UV layout, it will fit them inside of the UV space. So it's just a very simple tip on how sort of very basic UV tools work. And if you want to preview your UVs, you can usually, this has it built in, but you can type UV quick shade, and it will sort of quick shade your thing with UVs or with the texture. Like I could put some bricks on it if I wanted to. So anyway, so this is the visualization built in. But again, we don't really need the UVs, but just to sort of show how that works. So let's just put a null after this so we get rid of the visualization. Let's just subdivide the whole thing. So the top thing will look a little bit weird, but that's fine. We could maybe fix that if we put down a, let me just think about that a little bit. Let's play for it a little bit. So if we put down a divide and then convex polygons, I'm not sure if that will give us better results. This actually looks worse. You know what? Let's just keep it like this. Looks good enough. We're gonna create this into VDBs later anyway, so it doesn't really matter. Right, so we can skip the subdivide thing here. Maybe we want to add a smooth. Maybe we do want to subdivide, so the thing on the top does sort of smooth down like that. All right. So now we get this thing. And now if we look at the original graph here, you see we split from here. So this is the base shape. And then from here, well, actually already from the top, we split into a whole bunch of different directions. So let's pick a direction. So if we look, what I'm doing on here on the right is I'm creating a shell from my thing. So I think maybe it will be better to start with the tentacles first. So the tentacles will branch out from the copy to points. So if I go on here to the left, so let's just make it easier for ourselves and put down a null. So we can just use a null to sort of redirect it. So let's put down a null and let's connect it here on the left to a copy to point.